everybody. So this is just going to be a quick video that kind of outlines the major concepts with projectile motion. Now, one thing to keep in mind about projectile motion is it's actually not any new concepts, despite what I just said. We're just taking what we already know about describing an object's motion and applying it to a new situation, specifically a situation where an object is in free fall in the y direction and has constant velocity in the x direction. Hopefully before watching this video, you guys have talked about the results of the projectile video analysis and simulation part of the lab. You've kind of come up with those general trends and the stuff about the range for projectiles at an angle. Okay, so we're going to talk about the two different kinds of projected objects. And the first is the horizontally projected object. So this is an object that is launched from some height and initially only has some horizontal velocity. So the two major problem types that you'll see is like something launched off of a cliff or a table, or you'll have something that is launched from a moving or dropped from a moving object like a plane or a helicopter, kind of similar to that free fall problem we did in class, but instead of moving vertically, this is moving horizontally. So since the plane is moving horizontally, whatever the package is dropped, it has some horizontal velocity as well. Okay, but the initial y velocity in both situations is 0 because these are launched horizontally. Okay, so the important part with projectile motion is separating out the x and y direction like we've been doing with forces, like we've been doing with motions, etc. So in the x direction, we have no acceleration. And the reason why is because we have no force, net force in the x direction. Why? Because there's no forces in the x direction. If I was to draw a free body diagram for an object that's horizontally projected, it would just look like this, just the force of gravity, because we're ignoring air resistance. Okay? So if I wanted to calculate anything to do about the motion in the x direction, right, I could use any of my kinematics equations. Now, these first two, if I was to plug in an acceleration of 0, those last terms go away, and they just tell me that my initial and final velocities are the same, which makes sense. If I have no acceleration in the x direction, then my x direction velocity should stay the same. So down here, if I plug in an acceleration of 0, then this term, first term, still exists. So really the only equation we can use in the x direction is this third one, and it simplifies to the change in x, or the range, is the velocity times the time. Now remember, this time variable depends on y direction stuff. Okay, so even if we launch this thing faster horizontally off the cliff, it's not like it's going to spend more time in the air. The only thing that's going to impact the time in the air is y direction stuff. So let's talk about the y direction. Ooh, my screen froze. Hello. There we go. Okay. So in the y direction, we're going to have an acceleration of g downwards. Now, I didn't write positive or negative because remember, the positive versus negative either depends on the question or depends on you. You get to choose the positive versus negative direction. So I'm just going to say downward for now. So we're going to have an acceleration of g downward. Why? Because my net force is going to equal the force of gravity downwards, because only the force of gravity acts, right? So if I set my net force, remember any net force is going to equal ma, and if a has a value, then the net force is going to equal ma. So I set fg equal to ma. So I got mg equals ma for this free falling object. So I got my acceleration equals a. Okay. So to calculate anything in this y direction, all of these equations are going to work, okay? Because this acceleration here is going to have a value. It's going to have a value of g downwards. Again, depending upon what you choose the positive direction to be, could be positive or negative. If you choose up to be positive, g is going to be negative. If you choose down to be positive, then g is going to be positive. Choose a positive direction, stick with it, okay? Some important things to remember with this horizontally projected object. Our initial y velocity is 0. We are horizontally projected, so we have no initial y velocity. And usually our change in position is equal to the height of our cliff. Okay. All right. So that's horizontally projected objects. Now, even though I listed all of these equations, what we want to focus on is graphing and how changing those initial conditions, like how would changing this x direction velocity, how would changing this height change final conditions, like how would changing the height change the time? How would changing the x change the time? Spoiler alert, it won't. How would changing the height change the range? Well, changing the height is going to make more time in the air. More time in the air is going to mean we're going to travel farther. So focus on things like that over being able to use or do calculations. We're not going to do a lot of calculations with projectile. It's going to be more so qualitative or conceptual than quantitative. And with graphing, we've already done the position and velocity graphs for the x and y direction. We did it with the free fall velocity graphs, or free fall video analysis. So you should be able to predict what the position versus time graph and velocity versus time graph looks like for the x direction and for the y direction. So we'll let you guys figure those out. Okay. Then the other problem we would have, or we might see, as an angled projectile. So instead of being launched completely horizontally, we're launched at an angle, which means we have some x direction velocity and some y direction velocity. So remember, this x direction velocity represents how fast we're moving horizontally at time equals 0, and this y direction velocity represents how fast we're moving vertically at time equals 0. And those are components of the launch velocity. And we can find components of velocity just like we can find components of forces, right? Just doing SOHCAHTOA. So in the x direction, we're again not going to have any acceleration for the same reason as the other projectile. Our free body diagram looks like this. There are no forces in the x direction, so our net force is 0. Therefore, our acceleration is 0. So this x direction velocity, which once we do SOHCAHTOA here, would be calculated by doing v cosine theta, it's going to stay the same. It's not going to change at all as we fly through the air because there's no forces to cause any change in velocity. Okay, so that range can be calculated by doing that x direction velocity times the time. Now remember that time changes if anything in the y direction changes. So that could be height, that could be y velocity, that could be acceleration, things like that. Okay? In the y direction, our initial velocity is no longer going to be 0. Instead, we're going to have some v sine theta, and usually that v sine theta is upwards. But of course, there are some times where maybe we're on a cliff and we launch an angled projectile downwards. So sometimes our initial velocity could be downwards, but usually it's upwards. We have an acceleration of g downwards. Again, the force of gravity is the net force. Remember that if there is a peak as we're launched upwards, the velocity in the y direction at that peak is 0. Okay? We still are moving forwards. We still have a vx, but our vy at that peak is 0. And all these equations work in the y direction for the same reasons I explained above. Okay? So again here, we're not going to focus on calculating. Okay? We're going to focus on how changing the initial variables affects the final variables. So that entire conclusion page of the projectile video analysis, that's sort of what we need to know about projectile problems. Okay? And then, of course, also being able to graph the motion of the object as it flies through the air. So you should know what the x position is going to look like, what the x velocity is going to look like, what the y position is going to look like, and what the y velocity is going to look like. Okay? Now, one of the concept builders I'm going to assign due on Wednesday is going to help us with focusing on these sort of things. How does focusing on graphing some of the basic underlying concepts? Okay? The problems that you work on today is going to, or are going to, focus on how does changing the initial variables affect the final variables, focusing on that instead of calculating. Okay. So again, be able with both types of problems, be able to say, all right, if I increase the height of this cliff, right? How does, naturally it erased things. Okay. How does the time of flight change? How does the range change? Things like that, right? And remember, the time of flight is going to impact things in both the X and Y direction because time shows up in both X and Y direction equations. So time depends on the Y direction, but does impact the X direction. Okay. All right, so that's our focus for projectiles, focus on conceptual stuff over calculation. The end.